Assalamualaikum dan selamat sejahtera. Okay, so we move on to the next one. Okay, we are going to learn how to draw diagram to show refracted wave. This is very important to show the wave pattern in deep area or shallow area. Okay, so we begin with draw a boundary line to separate deep and shallow region. So this is the boundary, the shape. Okay, boundary. Okay, so next we draw a line to represent the direction of propagation of the incident wave. Normally we draw a straight line like this because we have the dipper here kan. So this is the dipper, it will vibrate. So you dapat something nanti lah, okay? Alright, next mark with an arrow. Arrow means the direction of the waves coming from left to right. Okay, so here is the point. This point is we call it as O. Okay, now what happen is we draw a normal line. So we draw a normal line. Remember, normal line always perpendicular to the boundary. So here is the normal line. Okay, next we from O, draw a line to represent the direction of propagation of refracted wave. So, we learned just now, when wave propagate from deep to shallow region, the refracted wave bend towards the normal line. So, how to draw bends to a normal line? So, here is the line before in deep area. So, if it does not change direction, it will go straight like this, right? But it will move towards the normal line. So, here is the normal line. So we draw towards the normal line like this. Okay. Right. Next, the wave will come to the deep area, right? So let's say we mark the point P here. Now again draw the normal line. Normal line always perpendicular to the boundary. Okay, draw the normal line, and then we decide that it will move from shallow to deep. So the speed will increase. Okay, therefore it will bend away from normal line. So this is the normal line. If it will not bend, it will go straight like this, right? So when we say away, so you down from the original line like this. So it will bend to downward. So it will bend in like follow this direction. Okay. So then we get, now you get the direction of the wave in deep area, shallow area, and again deep area. Okay. Now the next task is we use the ruler to draw a perpendicular line that is perpendicular to the direction of the wave. So like this one is perpendicular. Okay. So this line represent the wavefronts. So they represent the wavefront. Remember, we learned that the wavefront travel perpendicular to the what you call it, the wavefront perpendicular to the direction of the wave. Okay, so direction always perpendicular to the wavefront of the wave. Alright. And also one more thing, we label what we call lambda. So lambda is always from one wavefront to another wavefront. For example, from here to here. So this is lambda 1. And in deep area, shallow area, from here to here is lambda 2. And again, go out again to the deep area. We represent lambda 1. One wavefront to one wavefront. Okay. Now, what we can see from here is lambda 1 is larger than lambda 2. And if you notice that lambda 1 in the deep area before passing the deep shallow area will equals back to lambda 1 after passing to the shallow area just now. Okay, so this is how we draw you draw a diagram to represent the refraction of water wave. Okay. Okay, so this is how you get the experiment. So you have to use a ripper tank. So here is a ripper tank. Okay, and you fill up with water, and then you put a perspex or a glass plate. Okay, so to represent the depth of the water. And here is the white paper. You see the shadow, the image on the white paper. Okay, and here is the lamp. The lamp must be on in order to see the image. Alright. Okay, so method, just now we discussed, we can go back again. Draw a line to represent direction of propagation of the wave. Draw the normal and at the boundary. Draw the line represent the direction of propagation. And draw the refracted wavefront. Okay. Okay, from deep to shallow. This is the deep because the lambda is bigger and here is the shallow. So this time is shallow region. You can see it will change from longer wavelength to smaller. So it will be closer. Okay, here we have an angle. So this is the boundary. Okay. Here is the refracted wave. Okay, refracted wave. Okay, it will bend a little bit. So bend to a normal line and the wavelength is shorter. Okay. Alright. Now we try to draw the diagram from the. Okay, so we have a triangle, rectangular, shallow. Represent shallow region. This is a deep region, deep region. So this is the incident wave. So the first thing is you draw the direction of wave propagation. So it will be go straight line. And this also will be straight line because the speed of the propagation of wave is parallel to the normal line. Okay, when parallel normal line, it will no bending, it will go straight line. Okay, next step is we draw the wavefront. So in the shallow region, it will be closer. So we draw a closer line like this. Okay, so this is the wavefront for shallow region. And then we continue with the wavefront in the deep region. It will become longer. Okay, like that. Alright, so this is lambda 1. This is lambda 2. Okay. Right, now we move on to shape like this. We have a shape, we have an angle. It's not rectangular, it's like trapezium. So deep, shallow, deep. Okay, again, this time we draw a normal line. So we draw a normal line which is perpendicular. Then we decide it will come in from deep to shallow. When deep to shallow, slow down. When slow down towards normal line. So we draw like that towards normal line. And then from shallow to deep, the speed will increase. Okay. So before that, we draw a normal line. The blue line is the normal line. Then we know that the speed will increase, so it will refract away from normal line. So something like this. So after that, we complete with the wavefront. So in shallow region, the direction must be perpendicular to the wavefront. So we draw a line like this, and then deeper region perpendicular. We get like that. So the difference is in shallow region lambda is shorter, deeper region lambda is longer. Okay. Right. Next from deep to shallow. Okay, deep to shallow again. But this time the shape difference. So we go straight and then draw a normal line, and then here from shallow to deep. From slower to faster, so away from normal line. So away we go downward. Okay. And then draw the wavefront in the shallow region, which is shorter, and draw a wavefront in a deep region, which is longer. Right, something like this. Okay. So this is how you draw refraction of wave. Okay, with different type of glass plate. Okay. Right. Next, so if you have a different glass, something like this is like convex. This is a concave. So what happened? So we get like this. So this is the wave passing through a convex glass slab. Okay. So follow the shape. So it will converge to a point. So this one, since this is a concave means divert. So we get something like this. So this deeper. So in the glass, we draw it closer because shallow, right? Shallow region, the line of wavefront will be closer. Okay. So next, okay, we have another question. Let's say we have a basin, then we fill up with water, so we get level like this, right? but the depth are not the same. So this is deep, this is what? Shallow. And we put a water droplet. So if a water droplet touch the water, it will produce circular wave. So macam uh, like you throw a stone, right? Inside a water pond, inside the pond, you will see a circular wave. So in this case, you will get circular wave, but different depth. So what you should do is, so this is what we get. So we have circular wave, but shallow region, lambda seems shorter here, and on the right side, it will coming deeper region, so lambda will be short longer. So something like this. So this is still the circular wave, but different wavelength. Okay. Now we have a vibrator. This is a plain vibrator. So we expect to get a straight atau plain wave, right? So what we should have here is shallow. Shallow should be rapat atau closer line, and deep water should be longer ataupun further to each other.